And yeah, there was this project that came up with looking at, finding water on the moon and seeing if we could do some other, resource extraction experiments. And I just kind of jumped on board, and it just has, this whole area of research has just exploded in the last 4 years during my PhD. And I definitely feel like I'm in the right place at the right time, because there's a lot going on right now.
Yeah, I mean, how surprised were you when they made the announcement?
So for me, the idea of water on the moon, so we've been very confident that we were going to find water in the polar regions of the moon. For the last few years now, we've been designing a lot of missions to go explore these areas in shadowed craters where we think there's ice. So this recent research, if anything, it's more of a bonus to us, more so than completely out of the blue. Because we're going to the moon anyway, we're looking for water, and what this new research is telling us is that there's potentially, so there were 2 papers that were released, and one is saying that there's potentially more craters where there could be water ice, and on a small scale, so they're quite easy to access instead of these big 10-kilometer wide caverns of death, which is what we were expecting. And then the other paper is saying that there's water in sunlit regions, and that was interesting because we were expecting, like I said, to go to these big, deep, dark craters, and so now we know there's conclusive evidence that there are water molecules in areas of the moon that are sunlit, which means that they haven't just vaporized into space, which we would expect because it's a vacuum on the moon. So we're trying to understand, how is that water stable? How is it trapped there? So that's really exciting. So we're definitely going, I imagine a lot of missions that are heading to the moon are going to be tweaking their experiments to try and help validate these results on the surface. Yeah.
So what missions have we got planned to go to the moon in the near future?
So from a European and British perspective, we have an instrument being built at the Open University, which is what I was involved in. So there's the Russian lander. So you might be aware of the Russian missions to the moon are called Lunar something, a number. So Lunar 27 is the one that we're working on. It should land around 2025, providing there aren't any more delays. And there's an ESA, so a European Space Agency payload, which includes a drill to drill into these areas of the moon where we hope there's some water ice. And then there's this, it's basically like a miniature lab, and we're going to sample some of the moon, see if there's any gases, any water or anything in there. But it's basically got a load of miniature ovens on this carousel, and we're going to heat it up and do some chemistry with it, and see if we can actually, even if we can't find water, can we make water using chemical reactions and magic and various other things. So that one is something that I'm involved in. I know there's a number of American missions going, and interestingly, there's a lot more private space companies developing their own rovers and landers. So it's going to be this explosion of interest in missions heading to the moon in the next five years even.
I think it's great because obviously I grew up, I was 13 when they landed on the moon. And, that's probably one of the main driving forces for me to do astronomy in the first place, was the moon landings. And I've had the pleasure over the years of talking to Neil Armstrong and one or two others. But this, look, you talk to people in general public and they don't kind of get how groundbreaking this actually is and what it means. I think it's unbelievable that that it's on the sunlit part of the moon. We've heard for a few years that on the poles it was detected, but not on the sunlit part of the moon. I think this is unbelievable. But what I'm going to do now, I'm going to open it up to our panel, our resident panel, and I think we've got a couple of others joined as well tonight. I think Mark Charles has joined tonight. He's somewhere on there. So I'm going to open it up to the panel, and they can ask you a few questions if you don't mind.
Yeah, go ahead.
Away you go.
Hi, Hannah. We chatted earlier on about basically testing with moon rock. You've actually used Apollo lunar rock. the original lunar rock, and you've actually pulverized it, in effect destroyed this piece of lovely historic piece of rock to test your your setup. So is this what you've used for Prosper, for the Prosper instrument, to make sure it works on Earth, and then hopefully 2025, or will you send it robotically beforehand perhaps, and test it on the lunar surface?
So, so what I've been doing, so we have the Prosper instrument, and they're going to be sampling for water and whatever else. And in my experiment, we're going to use some of the hydrogen that's already on board, and heat up the samples. If you heat it high enough, that hydrogen will attach to the oxygen that's in the minerals inside the rocks, and out comes H2O, the water. So what I've been doing is I've basically built like a rough model in the lab, and I've been trying it on minerals so we know what the lunar rocks are made of. So we've got some of those minerals here on Earth, so we're able to practice this experiment and try it out, and it was all successful. But realistically, I needed to try it on lunar samples, because lunar soils, because they're formed in a very different environment than what we have here on Earth, they do have different properties. Even if you've got the same minerals, the grain shapes and how they behave is all very different. So you have to try it really on lunar samples just to conclusively say, yeah, everything's fine, this is going to work. So I had to, well, so I requested the samples. I didn't think they'd approve it, because I'm saying I'm going to set them on fire and destroy them. But because, yeah, we're only using, a few tens of milligrams, they were okay with it, and it worked, which is excellent, and we're really excited about that. And so now Prosper will hopefully use that, the procedure that I've kind of developed, and then operate that on the moon in 2025, providing there's no crash landings or anything horrific that goes on, which tends to happen in space.
I think the exciting thing for myself and for Peter and people of our age group, let's say, is that it's going to be in our lifetime. We haven't got to wait 30 years, because I think you mentioned in one of your chats, I think it was on TED, your TED chat in 2019, it's always 30 years, isn't it? All the time, it's 30 years hence, 30 years hence, and then 30 years comes and it's still 30 years away. But this looks realistic. It looks like we're actually going to be able to see this happen. It's quite exciting. I think it's amazing. Prior to all this, as Peter said, we always, we knew about the water that's hidden in the dark shadows of the poles, in those craters that never get the sunlight. But this is actually in the daylight, side of it. That is a game changer, isn't it? Because it now says, well, there's going to be a lot more water available than we originally thought.
Yeah, I'm finding this a very fine line to tread at the moment, because I'm very much interested in resources and how that will support future space exploration. And although this is telling us that there's stable water in the sunlit regions of the moon, when you're talking about quantities, it's still small. There's still small amounts there. We don't know if we can use it for resources. So I don't want to necessarily jump and say this is it. This is the solution. We found it. But even like on a scientific level, it's really interesting, because it means that there's some processes going on the moon that this water cycle that's very different to a water cycle we have here on Earth, that we need to understand. So how is it trapped? How does the water get delivered there? Where is that water coming from? How does it move around the moon? And trying to understand that cycle, we could then apply it to other planetary surfaces. So there's a lot going on that it's just opened up more questions, and the scientists were like, oh, that's so exciting, let's go find out.
Well, before we get to Mars, we've got to get to the moon, and not long to go. I think Daz has raised his hand there for a question. Daz?
Hi, Hannah. Nice to meet you. Just a quick one. You were saying that you hope to be going on 2025, I think you said. Before, and then you mentioned all the independent people who will be sending up their own missions. Now, some of them, there's one due to go up in 2021 called Peregrine. And that's been supported by lots of industries who have all got their own little things. There's going to be loads of rovers going up on this, and apparently you can pick them out and mess them about inside the thing. But also part of it is that there is some companies that were talking about depositing cremated remains on the surface. What are you worried about? Are you worried about contamination of any sort?
So personally, I've always found it hard, the commercialization of space, because for me it's like the purity of exploration and the science. So I do find it a hard pill to swallow sometimes. Yeah, and how that can be abused perhaps, but because I think in terms of contamination, if it's kept on a small scale, I mean, it doesn't concern me at this point. I think this is where policy is going to be really critical. So I know there's a lot of people now moving into space law and trying to establish guidelines and structures for how we should be behaving in space, because now it isn't just limited to 1, 2, 3 nation space agencies. It is open to anyone who can get there. So it does concern me, and I hope that we can get everyone on board and go into space as one sort of unified species and all on the same page, but I think I might be a bit too optimistic there.
Yeah, because I think the Artemis Accord was supposed to address some of these issues, but as you said, I think there's 8 signatories at the moment, but one of the biggest ones that's missing is Russia itself, due to political issues and things like that. So yeah, hopefully we'll be able to control this spread of I mean, like I said, because if you're going up in 2025, there could have been hundreds of these missions sending up ashes and other things, depositing other things on the surface of the moon, and it there is a serious concern of, like I said before, contamination. So hopefully we can get this under control, and you won't have any problems, and you'll find lots of water up there. So
I sure hope so.
thank you.
Anybody else? They're all very quiet tonight. One of the things we were discussing here a few weeks ago, in future, obviously, eventually there's going to be a prospect of maybe a lunar base at some point in the far future. I wouldn't say in the near future, in the far future. And you were talking about law and space law, and we were talking about this. If bases are set up, you would have to have some form of law governed on. Let's say, whose laws do you run by? If you've got Russians on there, and you've got Americans, and you've got English, and you've got whichever nations you've got, whose laws do you abide to?
Oh, so this is kind of out of my expertise, but as far as I know, so there was the International Space Treaty quite a long time ago now. So I think everything in terms of these space treaties and these laws and so on, at the moment, I believe it's very much being done on good faith. I don't know if there are necessarily consequences for breaking the International Space Treaty or the Moon Treaty. So again, I don't know how this happened. How does this work? How do things work internationally? Does the UN get involved? I have no idea. No. And it's scary.
It is. I mean, if you set up a community on the moon, and it will happen eventually, a community on the moon, and somebody breaks a law, whose law is it, and what law is it, and who makes the laws? And it's like you say, you're optimistic in the fact that we can all work together. Will we all work together? That's the thing. But I think to do something like this, you've got to work together. That you can't not. But
it makes you think about the International Space Station.
Yeah.
They've somehow, at times, in fact, because they are reliant on each other to keep the place running and operating and keeping everybody alive. It's always like a good thing to have that in space, because it ensures that, because if people don't get along on the ground, then it could cause havoc in space. So having all these different nations working together almost enforces some sort of cooperation on the ground. So it could, it could be a positive thing. Again, I'm an idealist. I'm hoping, but we need to be realistic. But I'll leave that to the policymakers and the lawyers.
Yeah, because it was interesting. We had a guy on quite a few months back now, and he was a psychologist, and he works with the astronauts as a psychologist to work out when they put them on the International Space Station, are they going to be able to work together? Are they going to get on? And it's something I think that the general public don't consider. You just send people to the space station and you just do this and you just do that and it's just going to work. They don't consider that you've still got the human aspect as well. And
yeah, they I know they've done so many studies trying to understand what is the best number of people to have, because sometimes it's a challenge to have an even number, because then you can never win a vote and you can just have a stalemate. So if you ever have a disagreement, it's sometimes having an odd number is helpful. There are so many complexities to long duration space flight, and the psychological aspects of that.
Coming back to the water, how do you think that the water actually got to the moon in the first place? Because I mean, that's going to be a big question that a lot of people are going to ask. How did it get there in the first place? So
I think the top sort of contender here would be meteorites that have water on them, or any object that's striking the lunar surface. If it's got water with it, generally that water will vaporize. But what happens during these high energy impacts is that it causes high temperatures and this instant melting of the regolith, which is this upper layer of sort of rubble and dirt and rocks. And that instant melting of the rocks, some of those water molecules will get sort of mixed in with that. And when you have this melting, it instantly freezes. And that's how you get the glass. This instant freezing of this melted rock will form a glass. So you end up with these water molecules frozen in time in the middle of these glassy particles. So that's, I think, that would be my assumption as well. And in terms of the frozen water, again, it's thought that that's what happens. But if those meteorites strike a crater that's in permanent shadow, that water will just condense there and stick there, just because it's so cold, instead of just vaporizing. I would say, this meteorite supply.
The water itself is, I mean, we look at water on Mars, and obviously they're thinking that this is a very salty substance to enable it not to freeze. Is this a salty substance, or is this just straight H2O, as we would say?
So the salty substances that you get on Mars are thought to be these brines. So when they've seen these sort of like liquid flows, the only way that would be, because it does have an atmosphere on Mars, but it's so thin that in order to have a liquid, it would have to be so salty that it could remain in this liquid form. Whereas on the moon, there would be no liquid. There wouldn't be any brine whatsoever. So the only water molecules that they have would either be trapped within grains and rocks, or frozen. It's interesting because we don't actually know how the water is frozen. We don't know whether it's like a frost layer, or whether there's individual molecules dotted around various grains and buried to any depth. We have no idea. So that's why we're going to go explore them with these series of missions. So that one's very interesting. I'm excited to see how this frozen water is forming.
I bet you'd like to go yourself, wouldn't you?
Do you know what? So I get asked this quite a lot, and I am quite happy at home with all the space that I could possibly desire and fresh air. I just don't think I could deal with that sort of confined space. Maybe if there was, a civilization with some decent infrastructure, but I don't need to be in a tin can.
I think what you're saying is you like your creature comforts, really.
Yeah, and I don't need that sort of danger in my life. There's no, I'm quite content and satisfied with everything here on Earth.
Yeah. No, I'm the other way round. I mean, if somebody came to me tomorrow and said you could go to the moon, I'd be on that spaceship. Like, the only problem I've got is I don't like flying. There's an issue going on there somewhere. But I mean, at least in space you can't fall. That's my fear.
I think the view would be sensational, and that alone is the only thing that would draw me. For me, it's the dangers aren't worth it at this point. But if we have some sort of sustained pretty secure kind of way to get there and back, then maybe.
Okay. Well, what we're going to do, we're going to go to another track, and then we'll come back to the chat in a second. This is Supertramp, and I think this is a track about Hannah herself. It's called Sister Moonshine. There you go. It's all right. You're not on. There you go.
I thought you were calling it Supertramp.
What we'd like you to do, if possible, one year is to come along to Solar Sphere. We run Astro Radio is part of it's the media part of a festival we run called Solar Sphere. It's Astronomical and Music Festival, where it's aimed basically at outreach for children to a certain extent, but we have music on the one stage, and then between the music we have astronomical talks, and then we have workshops for children. We have Emma from Astro Cymru, if you've ever heard of Astro Cymru, Dr. Megan Argo, if you know Megan from I think she's at UCLan now. She was at Jodrell Bank. She comes along. And then Kath, who's in the chat, she's kind of the coordinator of that side of it. So we'd love you to come along one year if you could and just join in. We have some great fun. I think Dave's got his hand up. He wants to ask you something.
On the subject of outreach, on your bio, it says you actually were a finalist in the I'm a Scientist, Get Me Out of Here. What exactly was that?
Yeah, so it's fun.
Yeah, sounds good.
Imagine like your biggest fear of being judged by children, really bluntly, and you do that for 2 weeks. Yeah, Julian's done it as well. So basically, you enter this zone with other scientists in the same field as you, and you spend a week interacting with classrooms online, and they spend an hour at a time quizzing you about anything and everything. They can ask you their favourite space facts. They can ask you about your life. And then every day they have a vote, and the lowest scoring gets evicted from the team. And yeah, and quite remarkably, I ended up winning mine. And I think it's only because I was in my first year of my PhD, so I attended everything. I attended all of the classrooms instead of doing my actual research, because I was so excited. And I was terrified of being voted out. I don't think I could have hacked it.
I think this sounds like something for Solar Sphere.
I've got an idea. Yeah, I've got ideas going over in my head now.
Oh dear.
About this. Yeah.
Yeah, I made it to Wednesday.
Just before we get back to the serious stuff, I want to bring up the subject of ultimate frisbee.
Oh.
Right.
Now we're talking.
Now it's the rules for ultimate frisbee. I mean, I'm trying to get my head around them. I mean, I just put a little marker pen next to some start and play. Each point begins with both teams lining up on the front of opposite ends, zone lines. The defence throws or pulls the disc to the offence. A regulation game has 7 players per team. Scoring. Each time the offence catches a pass in the defence's end zone, the offence scores a point. Does this all make sense?
So, right.
Okay.
I can't understand the rules sometimes. Well, as in reading the rules.
Well, the best part of it is the team switching direction. Every time you score a goal, you switch around.
Yeah, that's pretty crucial, because funnily enough, throwing a frisbee is quite related to the wind direction. Yeah. So if you don't switch every time, then it becomes very unfair very quickly. So it ensures that wind doesn't influence the score.
Now the best rule I find is self-officiating.
Oh, that's the whole best part. No referees.
No, players are responsible for their own foul and line calls. Basically, I didn't do it.
No,
Players resolve their own disputes. What do you think of cricket?
I have to talk about the no referee thing, because
Go on, yeah.
It is. It's one of the reasons why I love the sport, because you can't have bad people who play, or if there are bad people, they don't last very long, because it is entirely based on being honest and being fair and being nice. Because at the end of every game, from grassroots to international world championships, you rank the other team based on their communication, how well they know the rules, how badly they fouled. And if you get consistently bad scores, then you don't get invited back. And there's, as well as the winner of the tournament, there is the winner of spirit. And it encourages just positive attitude. And when I taught it in school, I taught it in schools as well. And these kids who play football, they do awful things and cheat to each other. And we're like, miss, you fouled me. And then towards the end of the season, they would be correcting their friends and like, no, that's not ultimate frisbee. That's not how we play here. And became these polite young children. So I love the sport. I could talk about it all day.
Fun. I do like frisbee. It's good stuff. If your rules are complicated for that, what do you think of the rules of cricket?
Oh, see, I love cricket.
Okay, explain this. We've got our American visitors here. We've got worldwide listeners, as we said, 250,000 people around the world listening to our very words now. So here's the rules of cricket. You have two sides, one out in the field and one in. Each man that's in the side that's in goes out. And when he's out, he comes in. The next man goes in until he's out. When they're all out, the side that's out comes in, and the side that's been in goes out and tries to get those coming in. Sometimes you get men still in and not out. When both sides have been in and out, including the not outs, the winner is declared if there is one. Does that make sense?
Who's on first?
Right, it's obvious.
It's obvious. Frank.
I've spent too many years watching cricket with my dad, so that kind of makes sense.
Good luck with that. Here's the rules. We can go in the bin. There we go. Serious questions.
I reckon we ask. I'll get Freddie Flintoff in here one night for a discussion on that.
Let him explain it to us.
My brother was he was head groundsman at Kent County Cricket Club for many years, and he got me a private box there one year to go down and watch the cricket, and I fell asleep within the first 10 minutes each time.
The best part of cricket is the afternoon tea and the alcohol and the 5 days of...
That's the best.
Yeah,
bit.
the bar is just the best to be open.
Yeah.
So, frisbee on the moon. The aerodynamics.
Not so good.
160.
Oh no!
What would you like to throw a frisbee on the moon?
It would. There's no fun because the most fun part of frisbee is throwing it into the wind and realizing it could go, 300 meters in any direction. Whereas on the moon, it will just keep going, and that's just too predictable.
Right, that's the silly questions over. Back to the serious astronomy.
It sounded more like a whole description of Quidditch to me. But,
Yes.
Well, that was made up, wasn't it, for a book? So
is it? I thought it was real. I can't believe.
Yeah,
it.
that's
They
right.
do play Quidditch, actually. People do actually play it.
Yeah.
And they ride it like you, when you were a little lad, Pete. You remember on your little bobbin horse, like the brush.
What, completely broomsticks?
That's it, just like on a broomstick.
No. We could
Broomstick on the ground.
And the snitch is an actual person who just runs around dressed in yellow.
Yeah.
Which is excellent.
I'm glad you know what I'm talking about, Hannah.
Yeah.
I've actually seen a video of people playing this game.
All right, I picked up when Hannah was on about how they get the when they go to the moon and how they get the water out the rock, and she says we do this and we do this and we do some magic. I thought, yeah, so there's a bit of wizardry going on here.
Yeah.
That's all chemistry is. It's just magic explained.
Well, can someone explain what hydroxyl is? Because I never did chemistry at school. I get why the hydrogen gets to the moon, there's oxygen there, and if you can mix them, you've got water basically. But what is hydroxyl? Is it a form of water? I'm trying to understand what I'm reading.
So hydroxyl, well, if we think about water, H2O, so that's two hydrogens and an oxygen. Hydroxyl is OH, so it's one oxygen and one hydrogen. So it's missing a hydrogen, basically. It depends what you want. It can still perhaps be useful. We still have the hydrogen and the oxygen there, but I think the hydroxyl is bound to something. So because it's missing this hydrogen, it's charged. It's not balanced, so it has to stick to something else. So that's kind of my layman's understanding of hydroxyl.
So from what I've picked up, it's a combination of the hydroxyl being created by the hydrogen and the oxygen in there, and then the micrometeorites, the bombardment, is releasing things to form water. It's a bit of a chemistry process going on, is it? It's like a two-stage process.
There's definitely a lot going on, and another process that's really quite complex on the moon is this the solar wind, because you have a lot of charged particles in that solar wind which is constantly bombarding the surface because there's no atmosphere to stop it. So you have protons in the solar wind, and that's what hydrogen is. Hydrogen is one proton.
Right.
So you have this hydrogen that's constantly bombarding the surface, and sometimes it will bond to some of the oxygen, but also there's so much energy coming in, it can also break the bonds. So yeah, there's all sorts of unpleasant things going on up there.
Yeah. So these glass beads is when the meteor impacts, or the meteorite impacts on the lunar surface. It's a meteor first, of course. Then it's a lunarite. Is it? I don't know what the technical term would be there. Meteorite. That forms glass beads with basically the heat transference. On Earth, we get this. Have you ever come across Libyan glass?
No, I don't. Well, I don't think I have.
It's fascinating. Basically, it's when the sand, the silicon, basically it all melts on the impact. When it cools down, you've got a piece of Libyan glass. It can be polished up for jewelry, and in Egypt, certainly around the time of the pharaohs, it was used a lot for jewelry. It's just a lovely piece of what naturally would be glass, just strewn across this, the deserts.
And it's seen as this
the sand, yeah.
So it's this remarkable thing, whereas on the moon it's just everywhere and anywhere.
That's it. It's everywhere. There's glass beads. The reported glass beads are everywhere. So it's a long time it's been happening, isn't it? But within those could be trapped water molecules.
Yeah, and there's another type of glass on the moon, and it's called pyroclastic glass. So pyroclastic, you might think volcano, and basically in the early formation of the moon, when there was still like molten beneath the surface, it would rupture, and you'd have this molten rock from beneath the moon, and it reaches the vacuum of space and suddenly freezes, again forming these glasses. And they're really exciting because we have found some trace amounts of water and other sort of gases inside it. Not necessarily enough to use, but it tells us a lot about what gases or volatiles, we call them, from beneath the surface of the moon. So we've learned a lot about the interior of the moon through these pyroclastic glasses on the surface. And there were some pictures taken. So the only geologist to go to the moon, Jack Schmidt or Harrison Schmidt.
Schmidt, yeah.
So he took some images and noticed that there's some slightly like orange tinge to the soil, and this is because of the pyroclastic glasses. And that's why it's so important to send geologists and scientists to the moon, and not just these engineers, because the geologists are able to point out that's interesting, that's unexpected. We need to sample that. Yeah,
that's the difference, because it's all very well sending astronauts to the moon, but if they've only had a basic crash course in geology, they're not going to pick up on those finer points, whereas a geologist would do.
Yeah, and now astronauts, as far as I believe, are trained to degree level in geology now.
Really?
Under the anticipation that they will be going to the planetary surface. So they are trained, in field geology.
Yeah. Frank, you got your hand up there?
Yes, thanks. Hannah, I was wondering, supposedly there's a liter or two of water per every so many cubic meters. I guess I'm wondering, has anybody calculated how much water would be needed to do something, and then what kind of volume of regolith are we talking about processing then to get that? Does anybody have an idea how much water they're actually looking for to do something serious?
Yeah, so if we're talking about propellant, so using the oxygen from the water to use as propellant, then there was a number thrown out a few decades ago now as 1,000 tons of oxygen. So I believe that would be a metric ton per year. And they designed various number of processing plants and so on, but it all depends on how much oxygen we can extract and to what efficiency. So let's say you can get 10 weight percent, I'm just throwing a number out there. So if you had what's that? So if you had a kilo of rock, you would get 100 grams of oxygen. Is that right? Wait, yeah. So so you can actually, let's say, 10, whatever you process, 10% of that will turn into oxygen. So you're having to process a lot here. We're talking industrial plants to do this sort of work. But we're not. This isn't just. Sorry.
More than just the industrial plant. I'm wondering about the size of the collection, the size of the hole, the size of the mine we're talking about. Sounds like we're talking like an open pit mine, something.
I imagine, absolutely, I imagine that's what would be necessary, and I can see why this is of a concern to people, because they see it as damaging this incredible object out there.
Well, I'm not so much concerned about the damage of it. It's just, it's hard for me to fathom the amount of instrumentation and the amount of machinery that would be needed to pull that much product. I'm not even thinking about you know, the damage to the moon or anything like that at all. It just seems to me to be I mean, I've gone to open pit mines here in the States. You're talking mini Grand Canyons. We're talking large open holes. Yeah, it's a lot of work.
Yeah, and I imagine so that as part of, they've called it, I think it was the ISRU, so that's in situ resource utilization. So the ISRU roadmap, at least from a European perspective, you know, we're looking to have demonstrations on the moon of like small scale water production or oxygen production, and then using that to support a crewed mission. So that wouldn't be 1,000 tons. It would be a much smaller amount. So, but that's kind of like the current goal, is to get to a point where we can support crews on the surface if they were to live there semi-permanently. In terms of this large scale mine, this is definitely decades in the future that we're considering. Sure. But we're already to get to that point, you have to start somewhere. So we're already starting to have joint conferences in space resources with the scientists and engineers for space exploration with the mining industry, because we have the expertise, but we need to get everyone to sort of work together and collaborate, because at the moment, mining industry, they're not going to get involved unless there's some sort of economical
right.
Yeah, a point with,
and obviously you're going to have to develop, obviously you would have to then develop all kinds of technologies for utilizing the material that's there to make the machine. You're never going to be able, if you've seen, we make the dump trucks that go into an open pit mine here in Milwaukee. They're as big as a small high school. You're not going to ship those from Earth to the moon. You're going to have to build those from material on the moon. So this is kind of an endless, repetitive process of doing this. This sounds very interesting.
I think we're talking a long time away, aren't we? You know, the industrialization, basically, of the moon, isn't it? I just hope that we don't start destroying the moon.
Me too.
As we have done with the Earth. And you look what we've done in 100 years to the Earth. You know, are we going to do that again with the moon in 100 years' time? And
it's definitely important to identify areas that need to be kept pristine. So there are planetary protection, I say rules, but again, I don't know what happens if you break those rules. So Mars has it's quite interesting on Mars, because there are areas which could host life, but because of planetary protection, we can't go to those areas in case we contaminate it. So we want to search for life, but we can't go there to search for life. And on the moon, people are questioning, you know, should we be increasing the levels that we've applied to the moon, because we've kind of just designated it as this ball of dry rock, but now there's water and there's things of interest, and the Apollo locations, they should be kept, you know, as historical sites, and on the far side of the moon, it could pose a really awesome place to have telescopes to look into deep space, and we can't just contaminate all of that with you know, roving trucks and and digging mines and so on. So there are a lot of complications here, and I'm in no way qualified to answer those questions.
Yeah. What you got a thought there, Daz? Nope.
Sorry, I was muted. I was just thinking. I mean, like you said, we were talking earlier during the break about regulation and things like that. And I mean, with the moon, like you say, if we start stripping it of everything that is useful, I mean, to begin with, it's going to be the regolith that people will be after, because that's where the water is. That's where any other. It's the easiest thing to do. You start vacuuming that up with a vacuum cleaner or something like that. It won't be long before you've got nothing there really, unless you start digging down. And as Frank said, you're going to need some pretty big stuff to start doing that. And as you said, you've then got the heritage sites, as they call them, the moon landing sites and things like that. Plus, there's also sites where they've just basically crashed probes into prior to the Apollo missions and all that. And as I said, this comes under this new Artemis Accord, where they've all signed up, except for the Russians. And it's going to be a very strange whether or not we can collaborate with everybody. It's just it's something to be looked at. I mean, when you've got Mr. Trump training all his little Buzz Lightyears ready to go up into space and defend their space stations and things like that, because there's already been a paper that did come out a few months back where the Americans were talking about that if you have a base, then there's got to be a no-go zone around it. So that now smacks of basically staking a claim to the moon or parts of the moon. And I can see that unless with this accord and we can get the Russians on side especially, it's basically not going to be worth the paper it's written on. So I don't know if anyone's got any thoughts on that.
I think the militarization of space definitely concerns me. Again, this is where the policymakers and there has to be consequences to breaches of that policy and so on. But again, that's not.
No, got to do the basic research first, just like you're saying. You just got to figure out how to do some of the very simple things first, no doubt.
I mean, that's a question that's just actually come in from Stefan. He's just outside of Moscow, and he said he fears the he fears. I can't even say it.
The militarization.
It's not just me, Pete.
Oh, I'm having one of those nights tonight where I can't get my words out. But yeah, you know, he said he fears that, and he fears because the Russians aren't signing, his nation aren't signing up to this, that this could be something that eventually happens. But I mean, going back to the moon landings, I don't know if you're aware of this, Hannah, but when they came back from the moon, and I've got a copy of the document here, that the astronauts had to show their passports and sign a customs declaration to get back into the United States. And I thought at first this was a joke. And when I spoke to one of the astronauts, he said, no, he said, we actually did have to do that and declare the moon rock. And I thought, that's a job's worth, isn't it?
No, I also really liked how they quarantined the astronauts.
Yeah.
Because they didn't know if they were going to bring back, moon germs. And the only real danger, because there's nothing up there that we're aware of, was the dust. And Harrison Schmitt got sick from the dust because it was so the dust particles are so sharp and abrasive because they haven't been eroded from water and atmosphere and so on. And so getting those into your lungs would just sticking in that soft tissue. Oh, it's just, so that's absolutely a concern for people, for those looking to have humans on the moon. If you want to have long duration missions, there has to be a way to stop that dust just irritating the human body.
Several of the astronauts had that problem. But the lunar dust is, I said before, it's like talcum powder, but it's not like grains of sand on your beach, which are coarse and rough edges. These are sharp, barred, and they're being pulverized. They're glass-like. So when they get stuck in your lungs, anybody who works in a hospital or respiratory clinics or whatever, you're aware of the chest infections. You get Manners disease, you get asbestos problems, and all these illnesses over the decades. One of the later ones is fiberglass. If you think of GRP, glass resin plastics. Or reinforced plastics. Basically, these fibers float in the air of the factory. I worked with this stuff back in the 70s in Germany. It was new industry, and it's not for 25 years till you find out there's people with problems. Lucky enough, I wore a mask most of the time, but a lot of guys didn't. And this is what the problem with being on the moon is: you're going to be breathing this dust in. You can't help. When the astronauts got back into the lunar module, they took the suits off, depressurized, of course, and or repressurized, I should say. Took the suits off. And that dust was in the environment where they were inside the lunar module. They breathed that in, not knowing. It just seemed very fine dust. And this is a problem when you're going to live on the moon. Maybe Mars will be a problem. I don't know. I think Michael, yeah.
Yeah, just on top of that, I realised the later Apollo missions, the astronauts weren't actually quarantined on their return after Apollo 14. They realised that they didn't need to be quarantined on the return.
That's true, yeah.
Yeah, I think regarding the dust issue in the spacesuits, I've seen one of the prototypes of lunar rovers that they're developing in Houston, and one of the ideas is to have this astronaut suit that is built into the back of the tent or the rover or whatever, so that they climb in.
That's right,
and then seal up so that the suit never enters the inside air that they're breathing.
Yeah, I think that's a brilliant idea.
Yeah, but then you've got the issue of the dust is a nightmare for any joins or seals or mechanical things. So how many times can they put those suits up to the wall and back again before suddenly the dust breaks them? Yeah,
all these things we keep bringing up, Hannah. One of the reasons that I think that people need to be more realistic about how far these things go. What people are doing, like yourself, is so important, and it all has to be done. I'm just concerned that when the general public gets ahead of themselves and talks about terraforming Mars and terraforming the moon, that the disappointment in what that ultimately does would impact you being able to do the important stuff that what's going on here. Because I envisioned all of these things in my life myself, but the more I've become involved and the more I studied, the more I realize these are horrendous places, absolutely horrendous places. I'm becoming more of the opinion we'll go to these places like the International Space Station or like a submarine that goes to the bottom of the Pacific Ocean, and we'll do our business and we'll learn things, and these things will benefit mankind for sure. But I'm starting to wonder more and more and more about the realistic part of, at least within the next millennia or two, of actually terraforming one of these places. And I think a lot of young people are thinking, we're moving to Mars, we're moving to the moon. And I'm just concerned that would have not a beneficial effect to your work in the long run if that gets out of control and people don't realize what we're really talking about.
So this definitely comes back to things that David was saying earlier. As far as I've known, and then looking back in the literature and the history, there's always in magazines and so on about, we're going to Mars and we're going to live there, and you've got these concepts of these civilizations and colonies on these other planets, and it's something that we will always be aspiring to and looking forward towards. And it is hard because whenever we try to get public interest, they want the big story and the headline and the excitement and the drama.
Right.
And it's really hard to get that balance, because if you were to tell them, just the science and keep it really dry and realistic, then there wouldn't be interest and therefore there wouldn't be funds. So it's also absolutely, there is this disappointment of, oh, we're not there yet. I thought we found water 10 years ago.
Where's my flying car? Where's my flying car? You told me I was going to have a flying car.
but incrementally, there's progress. Yeah. Absolutely, yeah.
I think if we can produce water on the moon, that means we haven't got to take it there in the first place. Or we said reduce the amount that we have to take. 1 litre of water, I'm trying to remember my science from school, 1 litre of water weighs 1 kilogram, is that correct? So 1 kilogram of fuel is quite expensive when you've got to take lots of kilograms. So that cuts the cost down, and that means you can take more science packages on board or more industrial packages with you instead of all that water, as long as that water is produced for you when you get there.
Yeah,
there's a lot of loops that we haven't sorted yet, isn't there?
Yeah, so what we realised, so with the Apollo era and the space race in general, it was, we're going to go to the moon and we're going to do it fast, but it wasn't necessarily the best way, but it got humans on the surface and we got them home safely. But in terms of, if we want to do this, and especially, the next step was going to be, we need to go to Mars, but to do that, you need to have this reusable, sustainable approach to space exploration, because you can't bring everything with you that you need. A mission to the moon, it takes 3 days to get to the moon, it takes minimum 6 months to get to Mars. So the amount of infrastructure and supplies that you need, we just can't do that. We can't do that as a single-use mission. And that's why we've had to take this. So, well, you probably could if you spent a lot of money, a huge amount of money, but then you get to Mars, you do it once and you might get home again. But if you want to do this sustainably, we had to take a step back and develop all of the infrastructure and test all of the different technologies that we would need to have this sustainable approach. And it's slow, but it will pay off, I hope. Fingers crossed. I
just think there's a plaque on the moon which basically says that we came in peace on behalf of all human mankind, or on behalf of mankind from the planet Earth, words to that effect, paraphrasing, of course. Wouldn't it be fantastic if we could actually get there and do this work as the planet Earth, united as one, instead of all the politics that we have to go through?
Yeah, I'm sure we all agree.
Scientists all around the world get on. Why can't politicians do the same?
I don't know if you've been to a scientific conference where someone's announced something.
I'll retract my statement there. There is some skullduggery, but that's history of science, isn't it? There's always skullduggery.
Well, there's no weapons involved, so that's nice.
No, Flamsteed and Halley, they all had a nasty tongue, you know.
If the technology you work on does nothing more than help us learn how to extract some needed mineral or chemical here on Earth that we need, that we presently can't extract, that's where I hope these things ultimately. Dave works he works in hospitals. I work in hospitals. I built intensive cares, heart-lung bypass machines, anesthesia machines for years and years and years, all based off of the technology that they use to go to the moon. That's where I hope technologies help us as much as I do worry about developing the moon itself.
I was going to pass over to Daz in a moment. When you said technologies, the respirator, I always think of Jacques Cousteau and the diving. You know, he designed this aqualung, which is basically what we have now as regulators on everything, isn't it? Pressure gauges. The business
with Draeger, I think.
Yeah, Draeger. I wasn't going to mention the companies, but there you go. Yeah, Draeger. Yeah, very important.
Like ultimately, ultimately, I do what I do because I love it and I'm interested, and I'm so lucky that someone will pay me to do what I love. And yes, ideally, we want to have humans on the moon and space exploration and go be the explorers that we are, and hopefully it will pay back. And generally, technologies do. The amount of money that goes into research, often you can get back tenfold in profits. But yeah, healthcare or mining or prosthetics and all sorts of weird and wonderful things.
Offshoots.
Yeah, and that's always an absolute bonus, and you have no idea how it will pay back, but it always does.
If you look at the UAE mission to Mars right now, and what they're doing, that entire mission is based on primarily developing industry at home in the UAE. It's just a reason to do it.
Yeah.
And those types of, right. And that's where I hope those, I have all those hopes for those types of things.
Okay, Daz.
Okay, Daz. Yep.
Just a quick one, and basically you're talking about spin-offs. I thought of a really good business plan, and that's dehydrated water.
Just add water. Go on.
That would solve a lot of problems. I mean, the weight problem would be resolved and all that. And just to rehydrate it, you just add water. So,
you struck gold there.
Just got to do it economically.
Hey, look, that's a thinking. It's a thinking.
Get that copyright on it, mate. Patents.
I also
Ice 9. We're talking Ice 9 here.
Yeah. I mean, I also think not the discovery itself, looking on a broader aspect, is the fact that it's going to help us understand more of how the solar system was formed in the first place. Because each time we make these discoveries, it takes us one step further to understanding how the solar system formed in the first place. Because we've got lots of theories, and we're close. As I say, a lot of theories do work, but it just takes us that one step closer. It's that one more piece in the jigsaw puzzle. That's
most important.
Yeah, just the raw science of it, and the pursuit of understanding of how we are and why we are, and so on. But that doesn't necessarily always get the interest of the public. But for us, yeah.
Would you like to get your hands on some of those samples from Bennu? Because they've already discovered that there has been water on there, and there is water. Would you like to get your hands on that and smash that to bits?
Oh no, I could not. No, I mean, obviously it would be super interesting. I work with so there are a number of colleagues at the Open University who do a lot of research into asteroids, and they cannot wait to get their hands on it. But I'll leave that to them, because I wouldn't know what I was doing. And so it'd be wasted on me. I'd rather leave that to the pros who really appreciate what they're finding in those samples.
Okay,
I've just received a message, Pete, from Derek.
Yeah,
and Derek saying, "Oi, get off my land." This is a reference to buying an acre of moon.
Oh, that's
right. Which for $100, well, you can have a piece of the moon, and it's yours if you can get there. put a
Okay,
fence around it.
we'll go over to another track now, and this is from the Red Temple Spirits, and it's called Moonlight. He likes a bit of cake, does Julian? Don't you, Julian?
No, I like a lot of cake.
We're still wanting
That
that
is a lot.
talk. We're still waiting for that talk, baking with onions. I still
We'll get there. We'll get there.
Yeah. So, Dave, you've got a couple of questions coming there from a couple of listeners.
Yeah, we've got one from Tian in Japan. Are you interested, Hannah, in exomoon searches? We get exoplanets. What about exomoon?
Oh, see, that's it for me. If I can't see it, I know. If I can't see it, then it's kind of out of my remit.
Yeah.
But I think it's incredibly interesting. There's the idea of exoplanets in general and that search. The idea of trying to find habitable worlds. If we can find exomoons, that just blows my mind. Because I thought finding exoplanets were insane, and now we're finding satellites of those planets. Yeah, I find it incredibly interesting, but I couldn't answer any questions about it.
Yeah, I mean,
very
we're finding
difficult to
Jupiter-sized planets. You know, we're finding Earth-sized planets. We're finding moon-sized, you know, like our moon. I don't know. It's that's pretty out of the question, I think, at the moment.
Right on the very edge of detectability at the moment.
Yeah, we'll get there at some point, I'm sure. Jill in Dublin asks, Hannah, do you use a telescope? You must have looked at the moon through a telescope. Come on.
Yeah, so I as a kid, I asked for a telescope. It was I think it was from Asda, actually, from the supermarket. And I had it in my room for years because I did my undergraduate in Sheffield, and everywhere in Sheffield is uphill, and so I lived up a very tall hill, and you could see the moon over the city every night, and I'd always look at it through my telescope, which is lovely. But I've never really looked that much in at various other planets, you've got stars.
Yeah.
But I liked the transit of Venus across the sun last year. So at the Open University we set up just some of those simple, I forget what they're called, where you literally look at like the reflection of the shadow on literally almost like on a cardboard box. You don't even need like this fancy telescope stuff. And I was just like, this is so cool, just watching a planet transit in front of the surface of the sun in what is effectively a piece of cardboard.
So did you project from a telescope, did you project it onto a card, or was it like a pinhole camera?
I think, yeah, something like a pinhole camera. I don't even know. It was literally just, oh, this is happening, come outside.
Yeah.
And I just find it remarkable that you could see that with very little technology. I remember when I was teaching in schools, there was a solar eclipse happening, and I had some year 9s doing a test, and this one kid just would not fit. He was taking his time, and I just thought, do you know what? I'll give you the answers if we can just get outside and watch this solar eclipse. And this kid brought in, I was telling them how you could view it, and we had some pinhole cameras. And this kid, he noticed, I mentioned like welding glass, and he's like, oh, my dad's a welder, so I brought in some welding glass, and we were just looking at it too.
It's got to be the right number glass though, because otherwise it can be dangerous. When we were kids, we used to just get a candle, a piece of glass, and smoke, underneath it. So basically, suck the glass up. I realise now as I've got older, not the safest way to do it, but yeah, you do these things back in the 60s and the 70s. Jack in Milwaukee, he asked, what other moons in our solar system would you like to have a probe visit? What about Enceladus, water worlds?
Enceladus is definitely up there. The concept of, so it's got this icy crust, but almost certainly a liquid ocean underneath, and that is going to be a prime, like if there's going to be life anywhere else in our solar system, that is going to be the place to go. So if we could get some technology out there and dig beneath the surface, I mean, it's a few kilometers, I believe, but yeah, that would be remarkable.
I think it's quite a thick layer of ice, isn't it? But again, we've got this problem of contamination. We've got to be able to do this, drill down into this, get down to that water level without contaminating.
Yeah.
How do you know you've not picked up earth bacteria or whatever?
You try really hard and you cross your fingers, because life is really annoying in that it's really good at staying alive. There's some of these tardigrades and all sorts of things that survive. So it's hard. I'd like to think that we're getting better and better. but life always finds a way.
Practice makes perfect. I always remember as a young lad with a microscope, my first microscope that I had, a bit of water from a plant pot from the saucer, and you just look into it and there's this paraceum is swimming around. You think, oh, how did that get into there? The plant, it didn't come from the plant. It must have come from the air. Well, how did it get from the air into the plants, into the plant pot? Maybe it was on the rain or something, or on the wind. And it's just fascinating way life will find its way. Volcanoes, I always remember the story of Krakatoa. It blew itself apart. You end up with the son of Krakatoa, the little tiny island that formed, basically a desert island. And then over the 20 years, decades of time, you've got life on there. There's birds on there. There's new animals on there. And life finds a way, doesn't it? It is amazing.
Yeah, there was a really interesting story very recently. I don't know if it was Russia, where they had these worms that they revived from I don't know how many, like tens of thousands of years or whatever it was, and one of them has started moving. You just how on earth does that work? It's so incredible.
But that happens in the Sahara Desert as well. They're sunbaked and they go into hibernation. And as soon as that moisture improves, they're back again. I've got another question there. Nat in Wolverhampton. Is Sharon a moon or a twin body with Pluto? I think we open that up to the panel. Any thoughts on that one?
Well, I guess currently Pluto is designated as a dwarf planet.
Yeah. Not a proper planet anymore.
No?
It is.
This is the political debate we have.
I'm not saying whether it should or shouldn't, but as far as I'm aware, that's its current name, right?
But you should have
You're
been
correct, Hannah, yes.
The night we had Alan Stern on.
They actually orbit each other, don't they?
Yeah.
We know that.
I favour double planets. I do.
Double.
A double dwarf planet, will say, just to be proper.
A dwarf planet binary.
Dwarf.
Yeah.
I'll have a double dwarf.
Sergey, hopefully I pronounced that correct. Sergey in India. What would you have done if we'd not had a moon? No, that's an awkward one, isn't it? Because
that's a good one as well.
Where would you go for your water?
Yeah.
In what context? So sorry.
Well, sorry, Pete. Yeah.
Yeah, I think what he's trying to say is, if you hadn't have studied the study you're taking with the moon and the water and taken, what would you have done other than this?
Oh, that is a hard question.
Frisbee entrepreneur.
Aeronautics.
Within the fields of, I think I've always enjoyed physics, and engineering, but somewhere in the middle, and I've never really known where I fall in between. But I think anything to do with space exploration and enabling technologies and so on. So I guess Mars would be the next bit. But if I didn't do that, then I'd like to think I'd be in a beach hut in Hawaii selling cocktails to holiday makers. That's my alternative. That's my backup plan.
You'd be distracted by the ice cubes in the drink, though.
Can I ask an alternative one now, Dave?
Please, Frank. Sorry, Michael. Yeah, please do.
Yeah. If we didn't have a moon, would we have a space program?
Oh,
that's the thing, isn't it? Yeah.
I'd like to think that we would have done Earth orbit, perhaps.
Yeah. I've done a lot of reading on this subject recently to suggest that if we didn't have a moon, life wouldn't exist on Earth.
Yeah, that's true. That's another one, isn't it?
Yeah. And there's a lot of reasons. There's books written about this in particular. Yeah. It is actually the one of the main reasons we exist at all.
Yeah.
It is, yeah.
Yeah, because there's a lot of life that goes in the stages around the full moon, isn't it? Around the 28 days of the lunar orbit and that.
Well, not only that. I mean, if we hadn't had the moon in the first place, it wouldn't have caused the initial tides, which caused the moving of the oceans, which mixed up the acid. Started life.
Won't we still have? I think someone asked previously on another show. If we didn't have the moon, would we still have tides? Because I think, are there solar tides? Am I?
Oh yeah,
yeah.
There is a pull, isn't there? The sun.
And if we didn't have the moon, Pink Floyd wouldn't have had that brilliant album.
That's the biggest loss.
Peter might be out of a job.
Well, we might have got to Mars by now as well,
No, but I mean, I did mention this to Dave Gilmore when I did an interview with Dave Gilmore a while back. I said you got Dark Side the Moon wrong, didn't you? I said, there's no dark side. And he said, no, listen to the end of the album. He says, when the Irish guy says, there's no dark side of the moon. It's all dark.
It is hard because it's one of the very common misconceptions is that there is a dark side of the moon. When actually there's just a far side, which I think, have you seen that? Yeah, the illuminated image of the far side of the moon, and this is the side that we never get to see, and it's just that just gives you shivers.
Beautiful.
But it's still flat, though, isn't it?
Oh.
Let's move on. Let's not go there.
I can't.
Well, if you have a flat Earth,
Hannah,
if you got
just
flat
just
Earth,
ignore
you
it.
must have a flat moon and a flat Jupiter and so on. Anyhow, moving on from the flat Earth politics. Robin Nottingham. Now, Harry, are you sitting down? Can you take a compliment?
Go on.
Oh, might refer to Julian. He's a scientist as well. Robin Nottingham says, "Why are most scientists not as infectious as you? You are so enthusiastic." That might be for Julian. I don't know. It doesn't say.
So that is such a good compliment because I mean people often describe me as passionate, and I don't know if that always means passionate is in terms of enthusiastic or passionate in like an aggressive kind of way. So no, I'm glad that comes across. Thank you.
I'm curious because this Robin Nottingham, isn't that near Sherwood Forest? Robin Nottingham.
It's near Julian, isn't it? Julian's Nottingham.
Are you Nottingham, are you, Julian?
I'm Nottingham, yeah.
Oh, you might know him then.
Oh, I probably do, yeah. I know pretty much everyone in Nottingham.
Hang on. It might be Julian who sent it in.
Have you got any other questions from listeners there, Dave?
Not at the moment, but I've got questions. But remember, we did our questions without answers for the panel. I've got a couple of them. If anyone fancy having a go at that? Bit of fun.
Go on, let's have a bit of a quiz.
Are you up for this, Hannah?
What does this involve?
Well, it's like
questions,
it's
really.
questions, but there's no answers. We've got to provide the answers.
Oh, okay.
And it'll spark conversations off.
Yeah.
Yeah, you know. So I picked the subject of the Hubble Space Telescope. Right, question. Hubble's image of the Eagle Nebula is famously known as what?
I can answer that, but I'm not going to because I only imaged it the other day.
Well, you can't shout the answer out then. Daz has already said one. I said Frank just had his hand up. So
that's the Pillars of Creation.
Pillars of Creation. So what's he referring to? Pillars of Creation. It's those little fingers hanging.
Nebulas with the star-forming regions.
Star-forming regions, yeah.
Yeah.
They're tendrils, and inside there's in the cocoons there's new stars being born.
Yeah.
And eventually they will blow off the gases and dust that's surrounding them to emerge as bright new stars. So that's I assume that's what.
So I know on the image, the star or the new star is basically hidden by the gaseous nebulosity. Eventually, that's going to move out the way, and we'll have these stars shining there, won't we? Maybe they'll have
although NASA came out with some 30th anniversary images and infrared of it, and you can see the star a little bit more there once they went to infrared, I believe.
Oh, and in that case, then, since you just mentioned the 30th anniversary there, what is the nickname of Hubble's 30th anniversary photograph? They actually had a particular photograph, and they had a title for it. Can you remember?
If it's not Hubba Bubba, then I don't. Then
no, that sounds good though. Yeah. A particular nebula.
Yeah.
Okay. The Cosmic Reef Nebula.
Cosmic Reef.
I'm not familiar with that one myself. Apparently, 163,000 light years away. Yeah, and it always amazes me when we talk about 163,000 light years or any light year. It's a measurement of distance, where it sounds like time, doesn't it? So it's how far light would travel in 1 year, which 186,000 miles a second in a year is what. I always get mixed up with me billions, American billions and British billions.
To give it context, it's 8 light minutes between the sun and Earth.
Yeah.
So if you're talking thousands of years, you can sort of see how that just extrapolates into this utter madness.
It does, doesn't it? But what fascinates me about our astronomy, amateur astronomers, we look out and we look at nebulas, we look at stars, and you say, well, okay, that one's 4 light years away, that one's 10 light years away. So the light that we see has taken 10 years or 4 years to get to us. When we look at the Andromeda Galaxy, we're looking at 2.2 million years of distance away from us. That light has had to travel. So what was happening on Earth 2 million years ago? I was watching a documentary about Henry VIII and basically the politics of the day. And I think it was 15. You have to correct me on this. I'm not very good on the old English history, but I think it was around the 1530s or something like that. So I was trying to think what star is 400, 500 light years away. So I'm thinking of Orion. The stars in Orion or the Pleiades, are they 400 light years away? So the light that left at the time of Henry VIII, and it's just got here.
Mm-hmm.
I just find that mind-boggling.
There's a really fun thought experiment to do, Dave. If you're interested, you can go out and look in the inner tube or the interweb out there and find a site that gives you your birthday star. You put your birthday in it, and it tells you to go what star to go image with that. And I do that regularly for my grandkids and stuff.
Yeah, does it go as far back as the Big Bang?
Oh yeah. It's hard to find the young ones because of you get too close. But I'm close to 70 years old. I can find 70.
I think I've got a couple of stars. Just moving back to one of the readers' questions, one of our listeners' questions. Sorry, Hannah from Marcus in Sweden. When you look at the moon whilst out with friends, do you see beauty or do you see science running past your eyes like the Matrix? Is it just like?
I see it as this. It's this for me now. It's more tangible because I'm aware of all the things that are going to be going there, including something that I'm hopefully sort of going to be contributing to. And I just keep thinking, I can't wait till I can look at the moon and say I've got something on there.
Yeah.
And that I'm so excited.
That'd be fantastic. It's something that you have been part of will actually be on the moon.
Yeah, and even if it crashes, I can say I've got some debris on the moon.
That's it. Sure. Yeah.
Hannah, do you have a feel yet for the distance there? I know that when I was reading a lot on the Apollo space missions, I had an epiphany at one time how close it actually is. It's a very close object to us comparatively. We think with these big distances of other things we look at, you see a picture. Now they take some space mission pictures from far distances away, like the pale blue dot. The moon is right up. It's right out our door there, and that's a strange epiphany to come across.
I can imagine from an astronomer point of view, absolutely that closeness. Whereas for me, I see it as this big circle in the sky, and then have you seen that image of where the Earth and the Moon are in one image, and you can see actually. I thought we were a lot closer. I don't know why, but that kind of that image I thought was really powerful, where you could see both together.
It's mind-boggling. I love looking at the moon, just the features in it. I suppose if you're looking at the Earth without its oceans, you'd see the geology, you'd see all the land formations. With the moon, we see all its history there. You see craters. I mean, Clavius. Now, for me, when I look at Clavius, I think there's water down there.
Yeah.
Beforehand, I was looking in the shadows at the polar regions, and you can't see much in there unless the libration swings it forward or swings it, the South Pole towards us or the North towards us. And it's now giving me that thought, well, now on that sunlit side, there's water in that vast area. It's not just at the poles, it's all over the show and on the far side of the moon as well, but we can't get there just yet. But I love the science in that. And it's now giving me a new view. But it's not just that. You look at craters, you look at Clavius, it's one big, huge crater. But then you got bigger crater, you got other craters inside that crater. And then you got craters that have broken down the wall of the little craters. And you're looking at time, those smaller craters are coming after the big bombardments. And that's history in itself, isn't it?
Yeah, I find the more I learn about the moon, the more amazed I am.
Yeah.
As with anything, I remember for all his wonders and his woes, Richard Feynman, there was a famous quote that he, speaking to an artist, and the artist was saying, how can you appreciate the beauty of a rose with science? I know how complex and remarkable it is that this rose even exists, and how it creates this beautiful thing is so crazy and amazing. I appreciate it even more so. And that's kind of how I feel about the moon.
Yeah, for me, there's the mathematic thing, fractals, which I don't understand the maths behind. I'm not into maths at all. But back in the early 90s, when the computers were starting to become, the thing, graphics on your computer were getting better. Do you remember the green frog? There was a green frog on Windows. Some of you remember by looking at your faces there. And it was like, wow, look at how sharp and the clarity of that. I've got 256 colors. Wow, And that was just that. But then this bit of software came out, fractals. And I realized in nature we have lots of spirals. And if you look at the edge of a plant, basically you zoom in and you've got the shape of the fern. You go in deeper and deeper. You've got the fern, and you're going into the macro world, the micro world, and it's still there all the way through. That's fractals, and that's science in nature. The spirals are there throughout nature, whether it be plants, animal, whatever. It is. Science is great. We talk about nerds and geeks. It's cool to be a nerd in the 21st century. It really is.
That's right. I just get so excited by it all because the more you learn, the more amazed you are, and it's what a joyous place to be.
Once I realized what Earthshine was on the moon, now I never see a complete crescent moon. I'm always looking to see how much of it I can actually.
That's it. But when you think of what you're actually seeing there with that Earthshine, for our listeners, Earthshine is that when we see that nice crescent moon and we can see the other part of the moon lit up like that silvery, ghostly grey. And the full folklore was the old moon in the new moon's arms. And we can see the Maria, a pair of binoculars, it's amazing, isn't it? You just see the bright silver crescent and the rest of the moon. But what you're seeing is sunlight is traveling 93 million miles. It's striking the Earth, and the Earth is in space from the moon. I think if I remember right, it's 3 degrees in diameter, angular diameter. It's reflected because of the clouds. That sunlight reflects back to the moon another 250,000 miles. So it's taking 8 minutes to get to the Earth. It's then taking 1.5 seconds or 1.25 seconds to bounce off and reflect back to the moon, and then it's bouncing back again to the Earth, another 1.25 seconds, and you've got all this light bouncing around, and then we see the moon lit up. I go, wow, that's pretty, isn't it? But you think of the science behind it. It is amazing.
Yeah, I think as well.
Sorry, I got distracted there.
when I look up at the moon, I mean, I remember going out when Apollo 11 landed. When they landed on the moon, to actually, as a child, to stand outside and look up and think, there's a human walking about on there. You say that to kids today and they just look at you and go, so? But it was unbelievable. And when Apollo 8 actually orbited the moon, and to look out and think there's something going round the moon, and we made it and we've done it. But in future now, you see, we can all say, us on Astro Radio, we had the person who's got debris on the moon.
Well, hopefully not debris. Hopefully
I'll take debris, but ideally, yes, some actual science would be great.
Yeah, tipping on the moon.
There's so much to learn up there. I was telling David just recently, I never realized that the Earth, if you were on the moon in your water factory that you're going to build someday, that the Earth would always be in the same spot of the sky for your whole life.
Yeah.
This is something that I didn't realize until a year ago, and I've been kind of studying this stuff for a while too. It just never came across me. I'm always used to seeing these pictures from the Apollo spacecraft, and that was a little bit of an epiphany.
But we tend to think of the Earthrise from the Apollo images that were sent back from the capsule. So as it's orbiting, it appears that the moon rises. Yeah. So that's I think our perception of that, isn't it?
In the Apollo pictures, the Earth is always high in the sky, isn't it? Because they landed near the equator.
Yeah. They always landed when the moon was at a low angle.
Yeah,
otherwise it would have been 250 degrees plus. Yeah. But sorry. Daz.
I was just thinking, if it does go wrong and you have some debris on the moon, you can name the crater after yourself.
Oh no, I'm not high enough. I'm not high enough the food chain to get that kind of credit.
There's a slight problem there. Well, one, Sargeant's crater sounds great. But the only problem is, I think you had to be dead to have the crater named after you on the moon, scientists and so on, or you have to be an Apollo or a lunar astronaut. So you got a choice there. Which one do you want? Be an astronaut or?
No, we don't.
Yeah.
I'm all right. I just, you know what? If I'm done, let's just make sure. I just need you guys to, campaign to get my name slapped on a crater somewhere.
Well, let's go for an asteroid. That's easier. Anyone can have an asteroid.
We're going to go over to another track, and then we'll come back for the last 5 minutes. This is Genesis and Dancing with a Moonlit Night. Bit of
I was going to say as well, Dave.
Sorry, Mike. Yeah.
The,
It's about the future of the moon. What was the point of it, Kath? What was you saying?
What I was just saying really briefly is obviously with all the science that we're going to be doing, I think we need to be very mindful of how we treat the surface of the moon, because in 100 years, 150, 200 years, children that look up into the sky are not going to see what we see now, and the worry for me is they won't see the moon as beautiful, and they'll have the pictures to look at, but they won't see that if we're not careful.
Mm-hmm. We got to be careful too, I think, to watch industry, Catherine, because more than one company has already talked about wanting to put up a billboard or something, near the moon, on the moon. And I think those would be more likely to pop up than the amount of mining that would take place. And that would be horrific too.
It would.
Yeah, because hasn't somebody put forward plans to build a nuclear power station on the moon? That's been looked at.
This is where we've been going with Space 1999. We know what happened with that place.
Yep.
What do you think, Hannah?
I would see it as when we've in the past, when we've gone and explored the world and these unexplored places and found this absolute beauty, and there are times when we haven't gone in with the right approach to begin with and destroyed them. But if you do go in with the right approach and you designate areas for like nature reserves and as an example, and just kind of it's all about that initial approach. Because if someone goes in destroying it initially, then everyone's just going to follow suit. So in my eyes, it's just policy is absolutely key at this point, and getting the policy straight before we get to destroying things.
Yes, hopefully.
Okay, so we've come to the end of the show. Thank you, Hannah, for coming on to Astro Radio tonight. We really, really do appreciate it. Round of applause from the chat.
Thank you for having me. It's been a pleasure.
You're welcome anytime. It's the same link. We're on Mondays, Thursdays and Saturdays. If you just want to drop in, join in, even make a request for some music, you're welcome to. We'll be back on Saturday. Now, it's Halloween on Saturday, and I think we all should be, those that are in the panel should be dressing up in something. I'm going to put my monk's outfit on. I think it's absolutely done, doesn't it? So we got on Saturday night, we got Pramvira Hassini from, she's from Kosovo, and she's presently studying in the United States. And we've got Thomas Bramwell. Now, Thomas is operations director for Primer Loose Labs in North America. He'll be joining us as well on Saturday night. I want to thank you all for listening to Astro Radio tonight. As I say, have a good evening, wherever you are on the face of planet Earth. It could be evening, it could be morning, it could be afternoon, wherever you are. We're going to leave you with a track now, and I think it's appropriate. It's Ticket to the Moon by the Electric Light Orchestra.